Dear students, today we are going to discuss about Laplace transforms. Module 4 Laplace transforms. In this section, we learn about Laplace transforms and some of their properties. Basically, transformation is a process by which a function is converted into another one of similar value. The Laplace transform, when applied to a function, changes that function into a new function by using a process that involves integration. Laplace transform has several applications in almost all engineering disciplines. Laplace transform is used to simplify calculations in system modeling, electrical circuits, etc. Then, how can we convert a function, or how can we find the Laplace transform of a particular function? Here its definition: if f of t is a function defined for all t greater than or equal to 0, its Laplace transform is the integral of f of t times e raised to minus st from t equal to 0 to t equal to infinity. It is a function of s, say f of s, and is denoted by L of f of t. Thus, capital F of s is equal to Laplace transform of f of t is equal to integral 0 to infinity e raised to minus st f of t dt. Here are some standard results of Laplace transforms. First one, Laplace transform of 1 is equal to 1 by s. Here its proof. Laplace transform of 1 is equal to, we know that the Laplace transform of a particular function L of f of t is equal to integral 0 to infinity e raised to minus st f of t dt. Here f of t is equal to 1. Therefore, Laplace transform of 1 is equal to integral 0 to infinity e raised to minus st into 1 dt. By taking the integral, it becomes e raised to minus st divided by minus s, limit from 0 to infinity. Since e raised to minus infinity is 0, the upper limit becomes 0 and the lower limit is e raised to 0, it is 1. Therefore, 0 minus 1 divided by the constant minus s. It becomes 1 by s. Now, the second result is L of e raised to at is equal to 1 by s minus a. And its proof. By using the definition of Laplace transform, L of f of t is equal to integral 0 to infinity f of t e raised to minus st into f of t dt. Here f of t is e raised to at. Therefore, Laplace transform of e raised to at equal to integral 0 to infinity e raised to minus st into e raised to at dt. We can combine these two terms and it becomes integral 0 to infinity e raised to minus of s minus a into t dt. By integrating, we get e raised to minus s minus a t divided by minus of s minus a, limit from 0 to infinity. Here also, the upper limit e raised to minus infinity becomes 0 and the lower limit e raised to 0 becomes 1, divided by the constant minus of s minus a. And the answer is 1 divided by s minus a. Okay. Then the third result, Laplace transform of t equal to 1 by s square. And its proof, Laplace transform of t equal to, by the definition of Laplace transform, it is integral 0 to infinity e raised to minus st into t dt. Here we use UV rule, and the UV rule or the Bernoulli's rule is integral UV is equal to uv1 minus u dash v2 plus u double dash v3 minus etc. where u dash, u double dash etc. are the derivatives and v1, v2, v3 etc. are the integrals. Here we can take u as t and the second function v as e raised to minus st. Therefore, by integrating, it becomes t into e raised to minus st divided by minus s minus 1 into e raised to minus st divided by minus s the whole square, limit from 0 to infinity. In the first term, for the upper limit and the lower limit, the first term becomes 0 since e raised to minus infinity is 0. Also, when t equal to 0, first term is 0. And for the second term also, for the upper limit it is 0 and for the lower limit e raised to 0 is 1 divided by s square. And similarly, we can prove that Laplace transform of t square is equal to 2 by s cube, and in general, Laplace transform of t raised to n is equal to n factorial divided by s raised to n plus 1. Then next result, Laplace transform of cos at, which is equal to s divided by s square plus a square. And its proof, Laplace transform of cos at equal to, by using the definition of Laplace transform, it is integral 0 to infinity e raised to minus st into cos at dt. And we know the result, we have the result, integral 0 to infinity e raised to minus ax into cos bx dx equal to a divided by a square plus b square. Just compare these two terms, these two functions. In this expression, a is equal to s and b equal to a. Therefore, the answer is s divided by s square plus a square. Therefore, Laplace transform of cos at equal to s divided by s square plus a square. Okay. And similarly, the seventh result is Laplace transform of sin at equal to a divided by s square plus a square. For this, we can use the result integral 0 to infinity e raised to minus ax into sin bx dx equal to b divided by a square plus b square. The next, linearity property in Laplace transforms. Laplace transform of a into f of t plus b into g of t equal to a into Laplace transform of f of t plus b into Laplace transform of g of t. The next one, Laplace transform of cos h at equal to s divided by s square minus a square. We know that cos hx, the hyperbolic function, is equal to e raised to ax plus e raised to minus ax divided by 2. Therefore, Laplace transform of e raised to at plus e raised to minus at by 2. By using the linearity property, we can write it as 1 by 2 into L of e raised to at plus L of e raised to minus at, which is equal to 1 by 2 into. We know that Laplace transform of e raised to at equal to 1 by s minus a, and by using this result, Laplace transform of e raised to minus at is 1 by s plus a. By taking the LCM, s square minus a square, the answer is s divided by s square minus a square. The next result, Laplace transform of sin h at equal to a divided by s square minus a square. The next, the first shifting theorem in Laplace transforms. It is, if Laplace transform of f of t is equal to capital F of s, then when multiplying with the e raised to at, that is Laplace transform of e raised to at into f of t equal to capital F of s minus a, that is s is replaced by s minus a. Okay, now we can consolidate the standard results as Laplace transform of 1 is equal to 1 by s, Laplace transform of t equal to 1 by s square, Laplace transform of t raised to n is equal to n factorial by s raised to n plus 1, Laplace transform of e raised to at equal to 1 by s minus a, Laplace transform of cos at equal to s by s square plus a square, Laplace transform of sin at equal to a divided by s square plus a square. The next one, Laplace transform of cos h at equal to s by s square minus a square, Laplace transform of sin h at equal to a divided by s square minus a square, and Laplace transform of e raised to at into cos bt. By using the first shifting theorem, multiplying with the e raised to at into cos bt. Laplace transform of cos bt is, by using this result, Laplace transform of cos bt is s by s square plus b square. So when multiplying with e raised to at, s is replaced by s minus a, and it is s minus a by s minus a the whole square plus b square. And similarly, Laplace transform of e raised to at into sin bt equal to b divided by s minus a the whole square plus b square. And the 11th one, Laplace transform of e raised to at into cos h bt equal to s minus a divided by s minus a the whole square minus b square. And the last one, Laplace transform of e raised to at into sin h bt equal to b divided by s minus a the whole square minus b square. Okay. Now, problems. Find the Laplace transform of the following functions. That is, we have to find the Laplace transform of the following functions by using the standard results that we have already proved. First problem, find the Laplace transform of sin square t. We know that sin square x is equal to 1 minus cos 2x by 2. Here sin square t, which is equal to 1 minus cos 2t by 2. And by using the linearity property, we can write it as Laplace transform of 1 by 2 minus Laplace transform of cos 2t by 2, which is equal to 1 by 2 into Laplace transform of 1 minus 1 by 2 into Laplace transform of cos 2t, which is equal to 1 by 2 into 1 by s minus 1 by 2 into s divided by s square plus 4. By using the results, Laplace transform of 1 is equal to 1 by s and Laplace transform of cos at equal to s by s square plus a square. By taking the LCM, the answer is 2 divided by s into s square plus 4. Then next problem, find the Laplace transform of t cube into e raised to minus 2t. This is by using first shifting theorem. For this, first we have to find Laplace transform of t cube, which is equal to 3 factorial by s raised to 4. By using the result, Laplace transform of t raised to n is equal to n factorial by s raised to n plus 1. Now, by using the first shifting theorem, Laplace transform of e raised to minus 2t into t cube is equal to 3 factorial by s raised to 4, in which s is replaced by s plus 2. Here a is equal to minus 2. And the final answer is 3 factorial divided by s plus 2 the whole raised to 4, or 6 divided by s plus 2 the whole raised to 4. Then next problem, find the Laplace transform of sin t into cos 2t. We know that sin a cos b equal to sin a plus b plus sin a minus b whole divided by 2. That is Laplace transform of sin 3t plus sin of minus t whole divided by 2. It is equal to, by using the linearity property, it is Laplace transform of sin 3t by 2 minus Laplace transform of sin t by 2. It is equal to 1 by 2 is a constant which can be taken as outside. 1 by 2 into Laplace transform of sin 3t minus 1 by 2 into Laplace transform of sin t. This is equal to, by using the result, 1 by 2 into Laplace transform of sin 3t is 3 divided by s square plus 3 square. It is 3 by s square plus 9 minus 1 by 2 into 1 divided by s square plus 1. By taking the LCM, s square plus 1 into s square plus 9, the answer becomes s square minus 3 divided by s square plus 1 into s square plus 9. Okay dears, here are some rules for solving the problems in Laplace transforms. First one, multiplication by t, and the second one is division by t. First one, Laplace transform of t raised to n into f of t, that is multiplication with the t raised to n, which is equal to minus 1 raised to n into d by d raised to n divided by ds raised to n of f of s. We know that f of s is the Laplace transform of f of t. For example, Laplace transform of t into f of t is equal to, here the power of t, that is n, is equal to 1. Therefore, minus 1 raised to 1, that is minus d raised to 1 by ds raised to n 1 of f of s, which is equal to minus of f dash of s. The next rule is division by t. It is Laplace transform of f of t divided by t equal to integral s to infinity f of s ds. Problems. Find the Laplace transform of t into sin omega t. For this, first we have to find the Laplace transform of sin omega t. Laplace transform of sin omega t equal to omega by s square plus omega square, that is f of s. Now, we have to find the Laplace transform of t into sin omega t, that is multiplication with t. The power of t n is equal to 1. Therefore, it becomes minus 1 raised to 1 into d raised to 1 divided by ds raised to 1 of omega by s square plus omega square. Omega is a constant since the derivative is with respect to s. Therefore, minus omega into d by ds of 1 by s square plus omega square, it becomes minus 1 by s square plus omega square the whole square into derivative of s square plus omega square is 2s. Therefore, the answer is 2 omega s divided by s square plus omega square the whole square. Now, the second problem in this section is find the Laplace transform of t into e raised to minus t into cos t. Actually, this is a combination of the first shifting theorem and multiplication by t rule. For this, first we have to find the Laplace transform of cos t, which is equal to, by the rule, by the standard result, Laplace transform of cos t equal to s by s square plus 1. And the next, Laplace transform of t into cos t, that is multiplication by t. The power of t is 1. Therefore, it becomes minus d by ds of s by s square plus 1. The derivative is with respect to s. Therefore, use the quotient rule. Denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. By simplifying the terms, the answer will be s square minus 1 divided by s square plus 1 the whole square. Now, Laplace transform of e raised to minus t into cos t. We already have Laplace transform of t cos t equal to s square minus 1 divided by s square plus 1 the whole square. Now, apply the first shifting theorem. The first shifting theorem is when multiplying with the e raised to at, the answer will becomes function of s minus a. The function in s will become function in s minus a. That is, s is replaced by s minus a. Here s is replaced by s plus 1. Since a is minus 1. Therefore, Laplace transform, or finally Laplace transform of e raised to minus t into t cos t equal to s square minus 1 by s square plus 1 the whole square, in which s is replaced by s plus 1. That is, s plus 1 the whole square minus 1 divided by s plus 1 the whole square plus 1 the whole square. By simplifying, the answer is s square plus 2s divided by s square plus 1 the whole square plus 1 the whole square. Okay. The third problem, find the Laplace transform of sin mt divided by t. That is division by t. To find the answer, first find Laplace transform of sin mt. Laplace transform of sin mt equal to m divided by s square plus m square by using the standard result. Then now, Laplace transform of sin mt divided by t equal to integral s to infinity m divided by s square plus m square ds. Integration is with respect to s, therefore m is a constant. Therefore, m into integral s to infinity 1 by s square plus m square ds. It is 1 by a tan inverse s by a, that is 1 by m tan inverse of s by m. Limit from s to infinity. It is equal to, these two m can be cancelled. Upper limit is tan inverse of infinity minus tan inverse of s by m, which is equal to tan inverse of infinity is pi by 2 minus tan inverse of s by m. And pi by 2 minus tan inverse of s by m is cot inverse of s by m. Therefore, our answer is cot inverse of s by m. Hope you have got the idea of multiplication by t and division by t. Now we have the last problem in this section. Find the Laplace transform of cos 2t minus cos 3t divided by t. That means division by t. By applying the linearity property, we can write it as Laplace transform of cos 2t by t minus Laplace transform of cos 3t by t. And we know that Laplace transform of cos 2t equal to s by s square plus 4 and Laplace transform of cos 3t equal to s by s square plus 9. Therefore, by applying the rule division by t, L of Laplace transform of cos 2t by t minus Laplace transform of cos 3t by t equal to integral s to infinity s by s square plus 4 ds minus integral s to infinity s by s square plus 9 ds. Here we have two integrals. We can solve this by integration by substitution. For the first integral, let s square plus 4 is equal to u. Then 2s ds becomes du and s ds is equal to du divided by 2. And for the second integral, we can let s square plus 9 is equal to t and 2s ds is equal to dt and s ds becomes dt by 2. Therefore, Laplace transform of this function becomes integral s to infinity 1 by u du by 2 minus integral s to infinity 1 by t dt by 2, which is equal to 1 by 2 into 1 by u du becomes log u minus 1 by t dt, that is log t. 1 by 2 is a constant for both. Limit from s to infinity. And in the first integral, our substitution is u is equal to s square plus 4. Therefore, 1 by 2 into log s square plus 4 minus. In the second integral, t is equal to s square plus 9. Therefore, it is log s square plus 9. We know that log a minus log b is equal to log of a by b. Therefore, it becomes 1 by 2 into log of s square plus 4 divided by s square plus 9, limit from s to infinity, which is equal to 1 by 2 into log of, we can take s square as common and can cancel the terms s square from numerator and denominator. It becomes log of 1 plus 4 by s square divided by 1 plus 9 by s square. Otherwise, by substituting the upper limit, it becomes log infinity. Okay. Therefore, 1 by 2 into log 1 minus log of 1 plus 4 by s square divided by 1 plus 9 by s square. Since 4 by infinity is 0, also 9 by infinity is 0. Therefore, the answer is 1 by 2 into minus 1 by 2 into log of s square plus 4 divided by s square plus 9, since log 1 is 0. Okay. Okay, dear students, hope all of you have got a basic idea about what is meant by Laplace transform and its basic properties, the standard results, and how to find the Laplace transform of a particular function and all. Thank you.